In this video, we're going to talk about designing an experiment. So an experiment measures the effect of manipulating the environment of the participants in some way. So will taking a drug relieve an ailment? Will going on a diet reduce weight? Will taking a training session improve short-term memory? So when we talk about an experiment, we have some kind of treatment. We decide who is going to be the group that is going to get the treatment. We have a control group. That control group may get no treatment at all, or they may get the gold standard. So for example, if we are going to be treating an ailment, rather than we do drug testing, we don't just say, okay, well, drug versus no drug. If there is already a drug available that is commonly available for that treatment, then we compare to the most commonly used or the best available drug. So when you bring in a new drug, you aren't comparing it to nothing. You're comparing it to the gold standard or the existing treatment to see if your new drug is better. Is it more effective at impacting that response variable? So we have our independent or explanatory variable, and then we have our dependent or response variable we're trying to change. So remember, when we look at experimental design, we are really trying to get to that cause and effect. If we do this, then this happens. Whereas our other research designs really didn't get to causality, they simply got to relationships. So we can conduct experiments on people, on plants, on soil. We can do experiments on production processes. So if we do this particular activity, when we make our automobiles, does that result in higher quality? Does that result in a faster time to market? So you can experiment on process, on events. You can experiment on people. You can experiment on animals and other objects. So if your experimental unit is going to be a human, then of course they need to have voluntary informed consent. So go back to our videos about research ethics in terms of having humans involved in research. If you are going to be treating animals, then there are also research ethic protocols related to dealing with animals. And so you need to make sure that those protocols are followed as well. So it's unethical to conduct an experiment without someone's informed, freely given consent. We did talk previously about if there needs to be some kind of disguise or deception, there needs to be protections to make sure you are not putting people's health or lives at risk. And if they are being deceived as to what they are actually volunteering to do, how that is disclosed to them after the fact, how they can revoke their participation. But as much as possible, unless you have a really compelling reason and a lot of oversight, there should be freely informed voluntary consent. People need to know what they are getting into. All right, so when we design an experiment, we have our control and our treatment, and we have randomization. So we are looking at the group that is the treatment versus the control, and that control could be the gold standard you're comparing it to. It could be a placebo if you're comparing it to nothing. So we need to be able to compare our group that's getting the treatment versus the one that's not getting the treatment, and the not getting the treatment is the control. We need to look at randomization. So how are where did I go? Oh, I'm getting ahead of myself. Right? Maybe. All right. So control group, yeah. Should just give up on the slides and just explain. A control group, right, is the group of subjects who are not getting the treatment. As we said, they could be getting the gold standard, that existing treatment. They could also be getting a placebo. So a placebo is a treatment that looks like the real drug, but has no active ingredients. And we do this because of the psychological impact. If you simply gave one group an injection and you gave the other group no injection, then the people who feel like they're getting no treatment will change their behavior, their mindset will be different, and that could be a confounding variable that impacts the response. So we want everyone to feel like they're getting the treatment, so the only true difference is the treatment itself. And that's why if we're doing like a medical study, we would give everyone a pill. Some pills would just be sugar, and some would be the active treatment, the active drug. And so everyone would act as if they had been given the real treatment, but then we're measuring only just the impact of that treatment itself. So if you are, if it's not a medical study, if it's not a drug study, if it is more of a procedure or steps, or you may have them do some steps or activity so that they don't know that they are the treatment group or the control. So patients are going to be blinded as to whether they are the control group or the treatment group. As I said, because you don't want the confounding variables of changing their mind, their perceptions, how they act otherwise. Okay, so the placebo effect is the observed change in outcomes among individuals assigned to the placebo group. So sometimes when you give people a solution, even if the solution itself is not effective, because people feel like they have a solution, because they feel like they have something, they will see a result. So for example, let's say we have a weight loss drug. We give it to the treatment group. The control group gets a sugar pill. Those who receive the sugar pill because they feel like they're getting something might see some weight loss, and then the treatment group you hope is going to see even more weight loss. So you want to have, if you're going to have, because of that placebo effect, you want to have a blinded study. So we want to blind the participant, as to whether or not they are in the treatment or the control group. We also do what is called a double-blind study, which is where the researcher also doesn't know whether they got the treatment or the placebo. And we'll do this ones where there's interaction between the researcher and the participant, because you don't want the researcher to treat the participant differently because they know that this person is taking the real drug or not the real drug. So we would double blind, which is, there's a record somewhere that says each participant, here's what they got, the placebo or the real treatment, but the researcher doesn't have that information during the process, so that it doesn't change how they interact with them. A single blind study is when either the participant or the researcher doesn't know. A double blind is when the researcher and the participant doesn't know. So you usually have double blind, researcher and participant don't know if there's interaction between the researcher and the participant. Single blind, it's going to be the participant who doesn't know because you don't want them to change their behavior if the researcher doesn't really have a whole lot of interaction with the individual who is in the treatment or control group. Okay. All right. So we have our control. We have randomization. So randomization is where we want to avoid unintentional selection bias by randomly allocating individuals to groups. So you'll recall in our previous videos about sampling methods and sample design error. Well, when we look at sample design error, we want, as much as possible, people in groups to have lots of similarities to each other, the only difference being that treatment versus control. We don't want people to self-select to one group versus another, so that there are some additional confounding variables that are causing one group to respond one way and one group to respond to another. So we wanted to have a random allocation in an experimental design because one group is going to get that treatment and the other is the control. So either you're doing a match paired, where you're saying, okay, 10-year-old, this weight, this income, this identified gender is going to be in this group, and a 10-year-old with all those same characteristics is going to be in that group, right? So they've been matched. Or here's your pool of people, randomly pick for each group so that there is the same level of variability, diversity in both groups the control group and the treatment group. As I said before, the other thing you might do is you might have a research project where you have the same person who is for a period of time getting the treatment, for a period of time they're getting the control, and so you're comparing the same person. And so that's another way to ensure that you're not having that confounding. So randomized experiment is a study where subjects are randomly assigned to receive either a specific treatment or be part of a control group. The randomized groups should be approximately equal and comparable in all respects. That's the issue of the confounding variable, except for the treatment itself. So example here of randomization. So is weight training good for children? A randomized experiment was conducted with 43 young volunteers, informed consent. And here we're doing an experiment involving children. So of course there's additional ethical considerations as a vulnerable group and making sure that parents are providing informed consent. So in this case, there's a study with 43 young volunteers between the age of 5.2 and 11.8 years old. The children are randomly assigned to either perform 6 to 8 repetitions with a heavy load, or perform 13 to 15 repetitions with a moderate load, or perform no weight training. After 8 weeks, the muscle strength of the volunteers is compared. So what we would do here is you can either randomly select, if we have enough people, we would select for the 3 different groups and hope that we're getting that age range in all 3, that variability of age range in all 3, or making sure that we have a 6-year-old in each of the 3 groups, an 8-year-old in each of the 3 groups, in order to make sure that, as we said previous, that they are equal or comparable in all things except for the treatment. Okay. So the principle of randomness is to reduce the likelihood that results of the experiment will be affected by confounding and other sources of bias, that the researcher themselves isn't choosing this person gets this treatment, this person gets the control. We don't want that researcher bias to be influencing. I like this person, so we're going to give them the drug we think is effective versus those who get the placebo. So we wanted to pull out the bias of the researcher. We want to pull out the issue of the confounding variable. We want really just to be measuring the effect of that treatment. We want to determine if the differences between the treatment groups is sufficiently large to rule out natural variability and attribute it to the manipulation of the explanatory variable. So if we're talking about a weight loss drug, treatment group on average, they lose 30 pounds. Placebo group on average loses 5 pounds. Is the difference between 30 pounds and 5 pounds big enough that it's not just randomness, it's not just natural variability, this particular group happened to lose more or less, but that it is truly due to the explanatory variable. So that's where we're going to get into statistical methods in terms of error, type 1, type 2 error, and statistical significance. As we compare those 2 groups, is there a big enough difference that it is statistically significant that we can say that this treatment does have a significant impact on that explanatory variable has a significant impact on the response variable. So randomized experiments are important because they allow us to determine whether there is that cause and effect that we can't get from other types of research design. So when you randomize your treatment, we want to have the type of treatment be randomly selected for each individual or experimental unit. We want to keep the researchers from making assignments that are favorable to their hypothesis. So one of the reasons for that double blind and for random selection is so that researcher isn't pushing some people to one group versus another to get the responses they're looking for. We want to protect from both known and unknown biases and for those confounding variables. So, randomizing the order of your treatment used when all the treatments are applied to each experimental unit. Randomization is used to determine the order each experimental unit gets the treatment. So, as I was saying before, one option, instead of having groups of different people, is to have the same people. For a period of time, they get the treatment. For a period of time, they get the placebo. If you're going to use that approach, then you need to randomly choose who gets the treatment first versus the placebo, who gets the placebo second versus the treatment. So the order of the treatment versus the control also needs to be randomly determined. And this particular type of design, again, you're only going to use if your treatment does not have long-term effects. Because in that case, let's say that we give you a treatment, we measure it for a period of time, 6 months, and then for the next 6 months, we give you placebo, control, no treatment. If there's a long-term effect and we happen to give you the treatment first, then in that second 6 months, you're still getting the impact of that first 6 months. And so then it looks like the placebo or control has the same effect as the treatment, where it is more actually that long-term effect. So we want to use this type where we're having the same person get both the treatment and the placebo only if the treatments have short-term effects only. All right, so we talked about control, we talked about randomization. The last thing I'm going to talk about here is replication. So when you are designing your experiment, we want it to be that if we're going to find that there is a statistically significant impact of our explanatory variable on the response, we'd like to think that if anyone else did this, they would get the same results. So we need a sufficient number of experimental units. So we need enough participants to ensure that the groups resemble each other and that we are then able to actually detect a difference between the treatments and then extrapolate to the greater population. So we want it to be that it's not just one person gets the treatment and one person gets the placebo and compare the two and that's it. Because we don't know. Maybe it's something unique about those two people. You want a big enough sample size, enough experimental units that the findings, we can be as confident as possible in the findings, and we can then make that statement about anyone who would take that treatment in the future from the greater population. So when we're designing our experiment, we need to think about control, our placebo versus our treatment, how we're going to put people into those different groups, how we're going to randomize, and then how we're going to ensure that the results we get will detect a difference if there truly is a difference.